Greetings YouTube, this is Tom. I have my military tube tester here in front of you. It looks a little askew because it's actually lifted out of the case. It has something holding it up on an angle. First time checking it, seeing if it works. I'm going to plug it in, and it's off camera. I'm not going to move the camera around. My camera is hanging off a wire, and it's very difficult for me to move it at this point. So I read through the instructions, which are on the lid up there. It's very basic how to use it. It's a military tester. I forget the model number. Oh, there it is. TV-3A/U. It's an equivalent to a Hickok 500 and something. I don't remember the exact model number. 563 or 53 or something. Tests all tubes down to a 4-pin, and including the modern Acorn 7-pin miniature, sub-miniatures, Novels. Does not do Nuvistors, but I don't use Nuvistor tubes, so it makes no difference to me. Those are the most modern, I believe. And then also, it has a function on here too for volts and ohms. You can use it as a volt and an ohm checker, but I wouldn't even use it. I have other equipment for that. Very good mutual conductance tester. Bought it out taking a chance that it worked. Seller didn't know if it worked. I have to confess, I've powered it up already, and I know it does come on. You can see my test light over here. What I want to test is a military tube here. And this is a one I've shown on a video before. And the reason being is this tube tester tests this, so I thought it would be fun to do. This is an RCA 446D. It's called a lighthouse tube for obvious reasons. It looks like a lighthouse with the light thing where it would spin. You have two separate metal rings here, and the cap that goes on here has an inner cap for the top and an outer cap for the outer ring, and the black one is the outer cap, and that is your grid, and the red one is the inner cap, and that is your plate, and those plug into here. Now I did look at the bottom of this tester. I think I showed it on another video. I went through and I sprayed all the switches with some oh, what do you call it? Deoxit. Deoxit 5. So this is an octal base, although it's missing 2 pins, but I think it's made that way. So that's going to go in here. Got a little flash, so that's good. We'll put our cap on, which, boy, it feels loose. You know what, I got another one. Let me use the other one. That feels really loose. There's 2 caps that came with this tester. That just barely sits on there. It just like flops around. It like it's bent. It doesn't fit tight. Yeah, this one's hard to get on, so let me sit down here. I have my mic and my camera hanging from a wire above the bench to get a shot of this. It's probably not the best setup. I eventually got to come up with a better way to do camera shots, but it works at least for now to look down on the top of the tube tester. Okay, that's on. I already found it in the roll chart. Now what I did find is in my roll chart, it's a 446A in the roll chart. This is actually a 446B. And just below it, the next one down is a 4A2, and that has an A and a B, but this is a 446, which is different. This has a 6.3 filament according to this. The other one is a 5 volt filament. So the 6.3 filament check is here, okay? And then these are the selector switches. So we have J, we have R, and then it's nice, it's filament. These are actually labeled what they are. Grid, although it's not on here, but it just tells you the numbers. 0, so our grid is 0. Our plate is 0, and I don't know if that's volts. I have no clue. Could be. The screen is 0. The cathode is 7. And suppressor is 0. Bias up here is 0. This is shunt, it's 0 as well. It's unused. Our micro ohm scale is C. It's on the C scale. It's going to be, I know you're never going to read this on camera, but it's this top one. And way up here in the corner it says D, C, and B through E. So it just changes the multiplication on the scale. It's the same scale. So we're looking for a minimum of 1510. And if I can sign a point, right there is 2000, as much as you can see it. Down here is 1000. So the middle, straight up and down, is 1500. And we're looking for 1510. So that makes it easy. We want to be past middle. So the first thing we're going to do is check for shorts. There is a bulb right here, and this is a short check. There's 5 positions. You can see it flashing, which is fine. As long as it doesn't stay on, we don't have a short. Back to the tube test. Now we do the line adjust. Push this down, and we turn the line adjust, and hopefully you can see the needle somewhat. I can see it on the screen over next to me on my computer. So we put that right in the middle, and that's also going to be about our minimum. We're looking for 1510, so we want to be above that when I hit the test button. So we're going to hit P3 and hope for 1510. 1, 2, 3, test. We're way above it. Beautiful. We're actually above the 2000. The 2000's hit my finger as much as you can see it. I know you can't read the numbers. So we're at about 22.5, 2,200 and 400. Yeah. About 2,200, something like that. 2,300. Between 22 and 2,300. So that's a good tube. More importantly, the tube tester is working, which is what I wanted to actually check. I took a chance on this tube tester. I got it cheap, being a good mutual conductance tester. As untested, didn't know if it worked, and actually the roll chart was not with it. It did not have a roll chart. I totally lucked out too and found the roll chart on eBay. The roll chart I paid a fair amount. I think total in the roll chart and the tube tester, I have like 160 bucks invested. And in good working condition, this tester is worth about 300 probably. So I got a good deal on it. That thing's warm. These are used for military things, I believe. I've never seen one before. I knew that this thing tested them, and I got one just for fun. I have nothing to put it in. I'm going to test another tube just for the heck of it. Well, let's go through. This is an 80 rectifier, I believe. Yeah, this is an 80 rectifier, so we don't need this cap. I could take that out. I suppose I could leave it plugged in, but okay, so let's find the 80. These are the tubes from the that Brown Emerson radio that I have. I actually bought a full set of new tubes for it, and I am still cleaning in here and looking, and I haven't found the new set. I know I have them. These are the originals. 80, 58. There we are. Okay, this is a 5-volt filament, which most rectifiers are. J, R, grid is 0, plate is 2. The rest are all 0, 0, 0, 0. Alright, our bias and shunt are both 0. We're on scale A, which is a shunt scale, it says right on there, interestingly. Rectifier tube. Oh, okay, there's 2 tests. We want to put this on 3 first. That's on 3 first for the first section. Plate 1 and plate 2, so there's 2 plates in this. Hopefully that's warming. Oh yeah, it's lighting up. I don't know if you can see it on camera. We'll do the short check. No shorts. Line adjust. Put it in the middle. So this is plate 1. And we're looking for a minimum of rectifier. There must be something on here that says rectifier. Okay. Yeah, I don't know how well you can see it. The very first line that goes up high here says rectifier with an arrow pointing that way. So anything above this line, right about there, is good. And we're going to hit P7 instead of P3. Here we go. 1, 2, 3, test. So we're good. We're above that line. And there's no number we're looking for. That's the first section. We'll change that 3 to a 2. And that's the next section. Same thing. We're looking to get above the line. Ooh, that's just barely above the line, but a little weaker. But that's a good rectifier tube. 80 rectifier. Alright. I got another one here, and I'm pretty sure... Is that the one that was... Yeah, I'm not sure this one's good. This is a 41 tube. Actually, I'll just test a few for the heck of it. I got a bunch of tubes all over the place around me here, within reaching distance. 41, 6.3, JR, 4, 2, JR, 4, 2, 3, 5, 0. Bias is 34. 34. No shunt. Scale B. We're hitting P3, and we're looking for a minimum of 1,000. And that's a, what is that? 6-pin. 6-pin tube. 1,000 again is about here. It's about a quarter. Well, it is a quarter the way from full scale. Well, actually, it's not quite. This isn't truly linear, but it's here. Well, it's getting warm anyway. I got a lit up filament. P3. Okay, first we do our short tech. No shorts. Line adjust. Get that in the middle. P3. 1, 2, 3, test. Well, that's pretty good. We want a minimum of 1,000 over here. We're at 15 something. The middle would be 1,500, so that's, 1,550 or something. That's a good tube. And there's no one test on that tube. I got another tube I do want to check too. Let me reach. Pardon me reaching. It's up on my shelf. I bought this to eventually build a region receiver, a 2-tube region, I think it is, or no, yeah, I forget what the other tube is. I think it's either a 1 or a 2-tube region, but it's a tube radio region receiver. Very simple circuit. You can build it yourself. This is a 19 tube. There we go. There's two sections to this one. Well, this only has a 2-volt filament. It is an older tube. Dates back, well, I don't know that this tube is that old, but they were originally made quite a long time ago. This is an RCA Radiotron made by Cunningham. And it looks, I think it was new old stock, and it looks pretty good. So, 2-volt JR4. I'm curious to see what this is because I've never tested it and I bought it. Is in working condition to build a radio kit from, well, to build a radio from. JR45000, bias 15. Shunt is nothing. Scale is B. It's a 6 tube. 6 pin. Yeah, 6 tube. 6 pin tube. We're looking for a minimum of 630. That's fairly low. So if 1,000's here, 500's here, 600 is there, somewhere between, about there, where my finger is. I don't see any filament lighting up on this tube. Oh, it's only a 2-volt though. It might be really dim. Let's do the short check. Nothing. Let's do the line adjust. P3 to test. Oh boy. That's not good. I wonder though, this tube is not, I don't see it lit up at all. It looks to be new old stock too, I mean. That 40 tube was a 6 pin, wasn't it? Yeah. I'm wondering if it could be the socket, but no, the 40 tube tested good. That was a 6 pin. Let's check my settings. 19. 2 on the filament. JR4 5000. Bias 15. Shunt 0. Scale B. Check P3 to test. Oh, there it goes. There it goes. It's not moving much, but it's moving. Ah! I'll bet this tube socket's dirty. Yeah. This thing is filthy. I really gotta clean it. The whole top of this had like this nasty yellow film on it, and probably tobacco. I cleaned some of it, but I gotta do more cleaning on it. And I'm sure that these tube sockets are just as nasty. So yeah, that's just a dirty tube socket. Yeah, we're getting good now because the minimum on that is 630. We're up at 1300 almost, 1250. Alright, this is a 2-section tube. We're going to go to the next section, which is going to be changing this 5 to a 2. That's the plate. And test. Well, I should do the short check on that too, although I don't. Yeah. Let me just check the line again too. It was off a little. Now that the filament's probably warming up in this, and it probably wasn't before I wiggled it. Okay, P3. Oop. I'm getting nothing again. JR. Oh. There's 2 changes you gotta make. JR3 2000. Alright, let's try again. There we go. That side's weaker. We're up over 6,500 though. No, see? I just got a dirty socket. That's 1,000. So it is a good tube. We're up to 1,000. The minimum is 630. Just got to clean the socket, this tester a lot. Clean it up. This has the original capacitors in it too, which, I mean, they're working. I don't know if I'll change them. It is a military unit. The one capacitor on the bottom, which I could show you. Let me unhook it and show you quickly. It's they're oil filled, and I know that because it's exactly the same kind that was on my SP600. And I replaced those, and I tried to open one of them because some people restuffed them, and I got it open. I tried to open it with heat. Well, I did open. Well, I tried. I did. Try is a good word. It didn't open. But what happened is the solder started to melt. I was using a hot air solder melter thing. And the, this is not tipping up easily. I don't want to, there we go. I don't want to pull on anything. Well, I'll show, it'll be easier for me to explain it if I show you what I'm talking about. For this, I will have to move this camera. Right here, this is a oil-filled capacitor. It's the one across the meter. And I did a little research on them. Turns out the oil has PCBs in it. And I was trying to heat one up, and it's spraying a leak, and the oil's leaking out. And I'm like, and it occurred to me as the oil's leaking out, I'm like, I wonder if there's PCBs in these, because there's oil, oil-filled transformers on, the old transformers for telephones had PCBs. So I looked it up online, and sure enough, there's people that said these did indeed have PCBs in them. So if I do replace this, I am not restuffing it. I did not restuff any of those, by the way. Once that thing started leaking, and I found out there were PCBs in it, that was the end of that job. So this is a Sprague. I know you can't probably see it. It's 100 microfarad, 15 volt. It would be easy enough to change, but you know what? It's just across the meter movement. It's low voltage. It's probably absolutely fine. I have no concerns about using it and leaving it in circuit. And they're probably really good quality, being that it is oil-filled with PCBs. And then there's another one there, which I'm trying to read. I'm trying to get my head around. I cannot quite make out what it is. Alright. So I guess that's it. I was just going to show you the bottom of this, and those are the only two capacitors in this thing, other than some mica ones, which I'm not worried about at all. I might just keep it and use it the way it is. It's working. Why mess with it? It has nothing to do with the power supply, either of those. They're not high voltage, I don't think. Thanks for watching.